In 1990, a team at IBM published a paper that said, "Forget grammar rules, just count words, just align sentences, let probability do the rest." The result was the ugliest, least elegant approach to translation anyone had ever proposed. And it worked better than every rule-based system ever built. This is the math that won the 60-year fight and broke everyone's idea of what counted as understanding language. Last 2 episodes, the rules era, ELIZA and SRDL and expert systems, all hitting the same wall. In V5, we met the empiricists at IBM and saw the famous Jelinek quote, "Now we go inside their lab. What did they actually build?" The answer was a translation system that did not even pretend to understand grammar. It pretended nothing about language at all. It treated translation as a math problem and won. Today's 3 beats. First, Bayes' rule and the noisy channel, the trick that lets you flip the translation problem upside down. Second, IBM Models 1 through 5, what you actually compute, the math in plain English. Third, BLEU and the cascade, how statistical methods spread from translation to every other NLP task in a decade. Here is the conceptual leap. Imagine the French sentence you are trying to translate did not start as French. It started as the English sentence you want and got corrupted by a noisy channel into French. Your job is to recover the original English. Why bother? Because this lets you use Bayes' rule. P of E given F equals P of F given E times P of E divided by P of F. The denominator is a constant. We drop it. So translation becomes, find the English sentence that maximizes P of French given English times P of English. 2 probabilities, 2 models. P of F given E is the translation model. How likely is this French sentence to come from this English one? P of E is the language model. How likely is this English sentence in general? Both can be estimated from data. No grammar required. Peter Brown and his colleagues at IBM built 5 models, each more complex than the last. Model 1 is the simplest. It assumes every English word generates each French word independently, ignoring position and word order. That is obviously wrong. It still works surprisingly well. Model 1 estimates 1 number for every English-French word pair. What's the probability that dog translates to Chine? You compute this by running the expectation maximization algorithm, M, across 1,000,000 sentence pairs. Iterate until the probabilities converge. No supervision, no human annotation, just data. Models 2 through 4 add position, fertility, and distortion, how words shift, multiply, or vanish across languages. Model 4 was the workhorse. By the time the team published Model 5 in 1993, Statistical MT was beating every rule-based system on real text. Not by a little, by a lot. And here is the secret weapon, the training data. The Canadian Hansard, every parliament debate, transcribed in English and French, sentence aligned, freely available, 3 million sentence pairs, the Rosetta Stone of the empiricist turn. Without it, none of this would have worked. Even with great models, you need to know if they are better. In 2002, Kishore Papaneni and his colleagues at IBM proposed BLEU, Bilingual Evaluation Understudy, a simple n-gram overlap score between machine output and human reference translations. BLEU was flawed. Anyone who used it could tell you it was flawed. But it was automatic. You could compare 2 systems in seconds instead of weeks. That made it the dominant metric for the next 20 years, despite every researcher complaining about it. And here is the wild part. The exact same trick. Bayes' rule, parallel data, probability, works for everything. Speech recognition, part of speech tagging, parsing, sentiment analysis. By 2003, every major NLP subfield had been swept by statistical methods. By 2005, the conference proceedings of the Association for Computational Linguistics, once dominated by grammar formalisms, were 80% statistical papers. The empiricists had not just won, they had erased the alternative from the field's vocabulary. 3 takeaways before the quiz. 1. The noisy channel and Bayes' rule turned translation into a search problem. No grammar required. 2. IBM Models 1 through 5, plus the Canadian Hansard corpus, plus M training, the first MT system that beat rule-based. 3. BLEU and the cascade. Statistical methods swept every NLP subfield within a decade. Quiz 1. What does Bayes' rule let you do in statistical MT? A. Skip the language model entirely. B. Flip the translation problem so you maximize P of F given E times P of E. C. Train without parallel data. Or D. Avoid using corpus data. B. Flip the translation problem. You can't easily estimate P of English given French directly. But after the Bayes flip, you can estimate both factors from data. And that's the move that unlocked the whole field. Quiz 2. What was the training corpus? A. The Brown corpus. B. The Penn Tree Bank. C. The Canadian Hansard Parliament debates. Or D. Wikipedia. C. The Canadian Hansard. 3 million English-French sentence pairs, sentence-aligned, freely available. Without it, none of this would have worked. The Brown corpus and Penn Tree Bank exist but are monolingual. Last quiz. What did BLEU enable in 2002? A. Perfect machine translation. B. Faster training of statistical models. C. Automatic translation quality scoring that replaced weeks of human review with seconds. Or D. The first rule-based system that beat statistical methods. C. Automatic evaluation. BLEU was flawed but fast. That made it the dominant metric for 20 years and let researchers iterate on models in seconds instead of weeks. The cascade across NLP came from this acceleration. Back to the puzzle. The statistical revolution did not just win translation, it killed the idea that you needed understanding to do useful language work. A system with no grammar knowledge, no semantic representation, could translate better than every rule system that pretended to understand. The empiricists had won, but they had also redefined the question. Next time, 2012, a single image recognition paper crushes every competitor. Within 5 years, every NLP task on Earth is redone with neural networks. Then 2017, the deep learning explosion. Hit subscribe if you want it the day it drops.